Okay, so I wanted to do a test to prove what I'm saying about these plugs, how they've changed. I ordered a Champion QL78C, which is equivalent to an NGK number 8, brand new plug, and I've got this old NGK B7ES, which is a number 7 without resistor. Supposedly, I measured it and it's like half a K. Usually spark plugs have about 5,000 ohms when their number signifies that they have a resistor. So riding on my motorized bicycle, this allowed some misfires. It was better than the Denso Iridiums that I ordered, but it still allowed some. This runs perfect still. The idea I have is that what's happening is that the electrical current is going through two different paths on these modern shit plugs. It goes through the center post to the center electrode and jumps the gap, creating a spark there. And it also goes through that center post through the ceramic to the grounded shell. And so having two paths of current, even though the path through the ceramic may be very minimal, is going to reduce the power here. The ceramic of the NGK was nearly perfect. Excellent formula that NGK came up with. So yeah, I needed a test to show that. So I took my motorized bicycle, removed the ignition cover, which exposed the stator coil and the magnet, and I ran the output wires from the stator coil to two different CDIs, which goes to identical high voltage coils, through new wires, new caps, to the plugs, and then the grounds of the two spark plugs going through a wire back to the engine. I was able to turn over the engine with the spark plug removed using my electric drill. This video is completely black except for when it shows the sparks of the two spark plugs. The NGK will be down here and the Champion will be up here. I had to do this in order to be able to see the spark using the camera that I used. This is the NGK and this is the Champion. Look at the difference in strength of the spark. This is weaker and more erratic. So normally a spark plug with a resistor is going to have a weaker spark than a spark plug without a resistor. But the opposite has happened here. Why? Because I believe that ceramic is letting current go through it. That's there's no other option. There's only two ways for the current to go. The correct way at the spark gap and through the ceramic. So I think that's what's happening. It's reducing the spark voltage because of what's leaking through the ceramic. When I did more of the dual CDI testing, once I received the Denso Iridium and the normal Champion, I found out that the NGKs were better than both the Denso and the Champion. Here's a conversation I had with ChatGPT, which I often refer to when I do research, and I explained the problem right here. That being that most all plugs that I've bought so far recently seem to have the same problem, and that I think the problem is in the ceramic. And the most telling thing that the AI told me is right here. It is possible that some raw materials or ceramic powders come from common industrial suppliers before being processed into final insulators by the spark plug companies. Being that all the major spark plug companies make their own ceramic. But if they're all getting their powder from the same source and something's happened to that source due to supply chain problems post-COVID, then that would be an easy explanation for what we see happening here. And here I explained to ChatGPT that I'm having to improve the voltage output of my system to compensate for this problem by getting a Honda CR coil. Many years ago, I tested different high voltage coils, and I was very surprised to see that the Honda coil put out like twice as much voltage as the others. And it was a coil from one of the motocross CR models. I don't remember exactly which one. And I'm pretty sure it was a long body. And so I ordered this new one, which is a replacement for the long body CR coil, on eBay, and just tried it out and was pleased with the results. It gave me less misfiring. And my next step is to try this used one that I just ordered on eBay. And this is the solution for these new plugs, which are not as potent as the old ones. And it's a problem mostly for the motorized bicycle riders and motorcycles that are old. Because with age, the magnets in the magneto lose strength. This is the '89 Honda CR250 that I owned when I lived in Amarillo, Texas. Go riding down the Red River. But it didn't want to start unless you push started it, and when you let the idle speed go down low enough, it would die. And I'm pretty sure it was because of the weak magneto. Unfortunately, which costs like $500 to get a new one. So other than upgrading your high voltage coil and making sure that your stator coil is not partially burned and making sure there's no rust on the ground connections for the ignition system, there's not much more you can do. And as far as evaluating plugs yourself, this was suggested to me by someone on my forum. It's a $25 spark plug tester, so if you got a known good plug, old style, you could put it right here and put the new plug right here and look at the difference in the spark between the two. So that would be a good way to test without having to go through all the trouble like I did with a dual CDI system. So I would like to hear your comments. Feel free to let me know what's going on with your spark plug situation. I guess the takeaway from this video is that NGK is not the worst one. I was thinking it was just an NGK problem, but now I see that Denso and Champion have the same problem. I'm going to try some other brands, but it looks like it's pretty much a universal problem now, and it may be due to low quality ceramic available to all the manufacturers. So it's a problem we're going to have to live with. And yeah, welcome to the end time. Thanks for watching.